Remaining 80% all the big MNCs, established companies, government companies, those kind of established companies. That is the current scenario. But if you look at the new jobs being created as on today, 50% are coming from the startups and young engineers. So, and whatever skill set is being gained by studying engineering, whether that skill set is suitable for startups, nobody has any clue on that. And definitely, it will not meet their requirement because every startup is working on different technologies. So, what kind of basic skill set? So, what kind of basic skill set is required so that any engineer coming out of the college can at least give a try in 1 or 2 startups just for the basic skill set, I mean basic digital literature or basic problem solving techniques. So those kind of techniques are required because from startup community, if you want to recruit someone, even as an intern also, we look for a lot of things because for startups, time is money and which we don't have. So if we have to spend even 1 rupee also, we think a lot, what kind of candidates we will get. And basic fact is like most of the projects the startups are being executed by either interns or fresh graduates. Because startups will not have money until they reach certain level, they can't go for funding. So interns and fresh graduates, they are like a fuel to any startup working on any technologies. So now the whole idea is that how do we cater to this 50% new jobs are being created, I mean the startups. So this is the skill set we look for when we want to recruit any person into any startup. Previously we used to tell students or some friends like that, jack of or master of none or master of one trade kind of thing. But now the real requirement is like we are looking for engineers who are like jack of many trades and master of a few trades. One or two. So that's the T-shaped skill set. If you look horizontally, they are all like generic skills like communication, collaboration, and the problem solving, digital. These are all the basic skills required for any engineer. And the vertical one is like in any one domain or 2 domain like motors, electronics, control system, that person should have an in-depth understanding of the fundamentals, not the advanced techniques or advanced things, because we can't expect advanced stuff from a engineering graduate. So at least he should have his fundamental should be strong. He should know what he is doing. And so that anyway your curriculum will be sufficient for that. But the horizontal part, this is where engineering colleges need to play a bigger role. The communication and collaboration, I mean the way we do experiments, where we put a team, because normally what will happen in a team, only one person will do, remaining all will copy the same report or same assignment. We used to do that. I don't know what is the current scenario. And even projects also, maybe 1 or 2 persons in the group will be doing, the others will follow or help them. But the collaborative nature has to come from college itself, because previously up to college education and then all the university, all the industries will try all the fresh engineers for 6 months to 1 year. But now the gap is not there. They are expecting from college itself they should be industry ready. So the training concept is not there in any startup. Even big industries also, they are reducing the tenure of this training, 6 months to 3 months, 3 months, 1 year to 6 months. So this is where we need to play a vital role. How we can make students ready with all these horizontal things. See, vertical bar is taken care with the curriculum, but the horizontal bar, the horizontal base knowledge. So that how we can inculcate all these things, like the progress learning skills. Because working in established company is different, because there are a set of rules, hierarchy, and everything is defined. Even if you use your brain also, but things will happen very smoothly. But when it comes to startup, it's chaos. you can't expect anything. I mean, you think that this project will, work fine, and suddenly some issue will come. At that time, what will it is, people who stood by their ground and solved the problem. I mean, we don't, any startup doesn't look at people who get panicked by, problems and all those things. So those things has to come from this 4 years, whatever you are with the experiment, the kind of experimentation, the kind of lab experiments, the projects, and the way you involve them in internship. So that can give them the expertise in this horizontal work. This is what everyone is looking for now. And even to do that, even your role as an educator also is being changed, because previously it was teaching. We have to deliver content or knowledge to the students, but now that is available everywhere. I mean, as I already mentioned, you take any AI tool, ChatGPT or Chinna or Cloud, you ask for something, they will give in a best possible articulated way, so that when you are reading, you are discussing with this other person or someone else is teaching you. So when the information is available to that extent, so then what else we can do as educators? So there your role is evolving from teaching to mentoring, or basically like guiding. I mean, they have everything, and what is right, what is wrong, that only you can tell, because ChatGPT cannot be, it's like a consultant, it will give options, you do this, you do this, you do this, but what to do? So the role of teaching has gone one step ahead. Actually, initially this was like happening in the training sessions in the industries, but now everyone is expecting that to happen here, so that the workforce coming out of the college is industry ready, so that we don't need another 3 months or 6 months training for the students. This is out of our startup founders, because I represent the startup community. So it is our selfishness to get industry ready students. So now, with whatever we have discussed as a more generic content, when we come to the electrical engineering graduates and the emerging career opportunities for the electrical engineers, I mean tripling guys. So if you see the first row, they are all emerging, like renewable energy or clean energy. Yes, I put the orthodoxy in such a way, what is the current priority now? See, you might ask, electric vehicles are the booming thing now, why did you put the electric vehicles in the first? Electric vehicle is like this consuming energy, but where is that energy coming from? Is it from fossil fuels or clean energy? Unless and until you are charging your vehicle with a renewable energy based or clean energy based, your vehicle is not a zero emission vehicle. It's just a zero tailpipe emission vehicle. If you are charging from a regular DG or regular supply, that's like you might have seen so many sarcastic tenants saying that one electric vehicle will be attached to a DC diesel generator, etc., and it will be charging that. So that is true. Until we establish the renewable energy, until we become energy independent, and from the past 2 years, we can't say any technology, any electric vehicle associated technology is clean. It is not clean. It is only reducing local emission, not the global emissions. So now the need of the hour is renewable energy or clean energy. So be it solar, wind, and there are so many other technologies are emerging, and energy storage systems also. And integration of these, because these are all micro energy generators. So how we are integrating into the grid, and what is the impact of the grid? And we have so many charging stations. What is the impact of connecting everything to the grid? So in this domain, there are so much employment is also being generated here, and even government is also pushing. Now I think you are aware of this PM Surya, where they are giving even heavy discounts if you install your solar panel on top of your roof. And now my question to you is, so how much course content is related to this renewable energy or clean energy? Do you have any full semester subject associated to this? Or is just one chapter in the power systems, or do we have a full semester course on the renewables?
Even we included energy storage systems also as a separate subject.
Okay.
Solar and wind energy systems course already included. And renewable energy systems offered as an open elective for all
It
branches.
should not be electricity.
No.
Renewable energy should not be electricity.
No, not for electrical engineers.
Okay.
For electrical engineers, that's a compulsory course. Even it is taken by computer science students also to study energy.
This is the power of freedom. And now the ecosystem is like everybody can start a company on any subject. It is not like electrical engineering can start only electrical related things. So one of our college alumni is start a company which collects the debris from the space. I think you might be Mr. Charanjeevi. He is from mechanical or civil. I am not sure. The company name is Cosmos Space. Mechanical engineering. Yeah. So it is such a niche things. I mean, it is not like because that's actually a robotics kind of application. So there is no bound to it. I mean, it's not like you are an electrical engineer, you should start only this. You are a mechanical, you should start only this. So under lab work, right? See, when you course content is something which is not in your control, complete control, because that is defined by university. So you have minimal control on it. And the lab assignments, what kind of lab assignment associated with this segment, and what kind of internships, and what kind of projects we are doing with this. Because there's so many companies in and around Hyderabad working on a vertical axis wind turbine. It's just, you can put here also, it will be, it just rotates in the circular flow. When I say windmill, don't consider those big, giant windmills where you can see on the mountains or remote areas. The small, this much this size wind turbine is also there. So that you can put anywhere. I mean, even if you close it also, if there is a turbine there, it will rotate and it generates electricity. So people are coming with that kind of smart technologies, and that is easy for experimentation also. So now my next question is, do we have experiments related to this segment? Whether it is solar, do we have any solar panel installed and doing something on that, or any small wind turbines, vertical axis wind turbines? Because the solar and the wind, you might think wind is a mechanical or aerospace thing, and semiconductor and solar panel is a semiconductor thing. But once the harvest the energy, the rest everything is electric. Suppose let's take a wind, it rotates, and just by rotating it to run generate energy, right? You need a generator attached to the wind turbine. That is a core electrical engineering concept. And once you generate, the generator generates AC, three-phase AC power. So that has to be converted to DC. So there is a AC to DC rectifier. So that is again the core power electronics, of electrical engineering. And then, since the speed depends on wind, output voltage also depends on speed. When speed increases, voltage increases. When speed reduces, voltage reduces. But you can't feed that to a battery. You have to feed a fixed voltage to a battery. So you have to take DC-DC converter. So except what you see, rest everything is the background of everything is being done by electrical engineering. So there are so many components. So there is so much scope for experimentation and internship and even project courses. That's the whole point I am trying to say here. The same way, solar. Now solar is everywhere. So once they generate that, after that harvesting, until you take to the battery and take to the load, the MPPT, all those things that you can start like a small project, incorporate in the lab assignments. I think we are still doing the same lab assignments. I mean, the load test, open circuit voltage test of transformers. So try to think in this context also, because this is the reality. This is where the job market is. So you have to train your students in this way, because nowadays only knowing theory is not sufficient for getting jobs or surviving the jobs. That is only for exam-based jobs, like you write here, you get good score, and then you will be eligible for so many government companies. So that's the difference. I'm not talking about that. After IT sector, you don't need to do anything. by virtue they will get their jobs. So you don't need to put any additional efforts to get, to make your employee, employed for IT sector. But when it comes to these startups, your effort is required. I think lab assignments are still in your scope. I think you have a leverage there, and you can leverage what kind of experiments you need to do. Or it is still defined by a board.
No, we are just an autonomous institution.
So you have full control over what kind of experimentation is required. And next, my favorite thing is electric vehicles and mobility. I don't name that like that. I will name it like electric propulsion. Because when we talk about electric vehicles, electrification, we only think whatever we see, 2-wheelers, 3-wheelers, 4-wheelers. But that's only one part of the electrification. Now, there is a mobility part, and there is other part of electrification like aviation, aerospace. So after recent war, Iran and USA, and the war, so drones are like, that declared, that gave a concept saying no country is small. Even country to minimum budget also they can buy drones required for warfare, and they can stand against any other big country. So now in India, around 10,000 companies are working on drones, and in Hyderabad 2,000 companies, because Hyderabad being defense capital. So every company working towards defense or aerospace, they are working on some drones projects. But from where all these components are coming? China. The same thing for mobility also. We make only vehicles. Components we import from China. Here it's a state, but that's the reality. And next big thing in the propulsion is actuators. Humanoids. You might have seen in the news. Elon Musk humanoid, Honda launched their humanoids, and even Honda is working on humanoids. So that's going to be the next big. Every big automobile company is working on humanoid projects. So they are all part of propulsion. So now, related to propulsion, so what is the coursework? What is the core coursework we have? Electric propulsion. Anything specific? We have all these generic, electrical machines, power electronics. That's the generic one. So do we have any such coursework specific to electric vehicle technology, or the battery systems, BMS, battery management? So do we have any such courses? Because this is going to create so many opportunities. Mobility already created so that now mobility is not new thing anymore. We are seeing interstate buses, electric buses being run by so many companies. Between Hyderabad and Bhimavaram, there are so many electric buses are running interstate, and intrastate also so many buses are running. So when this segment is creating so many jobs, so what is that we are doing to get our students ready for this kind of technologies? I'll discuss in detail in the coming slides. And the next big thing is industrial automation and industry 4.0. People talk industry 5.0 also, where industry 4.0 means every machine is connected. It's not like every machine data will be available. Now people are talking about industry 5.0 and even dark factories, where you don't need a human in any factory, and not even live. They will be humanized. It's a completely automated. They will do all the activities. So when automation is at that level, and it's going to create so many jobs also, because now the problem is we don't have manpower. Take agriculture. So definitely you must. Some of them must be from some village. We have some connect to some villages. So 10 years back, what was agricultural situation, and now what is the agricultural situation? Are we finding any workforce in the villages? Then so much automation is happening in agriculture. Because we are working with almost 10 companies in Hyderabad. They are mechanizing, automating the machines required for agriculture. Like instead of a conventional tractor, electric tractors, or autonomous robots, or remote control robots, where the farmer is sitting somewhere and close to his field, and he can directly control the bot. They call it a bot or robot, and the implements will be attached to it. So like rotovator, cultivator, all those things will be attached to it. And crop to between the farms also different horticulture, those things also maybe different machines, because there is no manpower. Because definitely farmer, if today's farmer, he doesn't want his kids to be farmer sector. He will say, I don't you do something there, don't come here. So there, most of us, we will be working with Zomato, Swiggy, or all these 10-minute delivery, 30-minute delivery kind of thing. We are destroying one generation of efficient workforce. And electronics and embedded system. Whatever these three segments we are talking without embedded systems, anything we want to control, we need a PCB, we need a hardware, we need a firmware. That comes from the embedded systems. Because when as electrical engineers, when we think about embedded systems, we think of this communication, electronics and communication systems. No, it's not. See, it is our subject only. It is our hardware. Whatever we learn in power electronics, and that's the hardware. Whatever we learn in the control system, that's the firmware. Because I see so many interns when they say embedded systems or embedded software, they no, we don't know C. C is not embedded system is something else. And in this also, because these three segments need electronics, are embedded systems. So without that, this kind of function, because all these UA systems, they have to work in tandem. It's not like you have a motor, you connect the plug and it won't work. You need a inverter. Everywhere they are close to control the systems. So motor and electronics has to work together. It's not like motor alone or controller alone. They have to work in tandem. Then only these three systems will work. So that is going to create so many jobs. And I'm not sure, I mean, do we have anything attached to the curriculum or any subjects or anything? And the same way AI data. This is like it has become a norm, like everybody should know how to work with AI. At least if you want to do something, you don't start with that. You take whatever is available. Even for this presentation also I took AI because I got only Saturday time, so I took all the help from ChatGPT and I prepared this. So in college you should make them well versed with AI tools. That's easy. It is simplifying a lot of things. Suppose if you want to write an email or prepare a presentation or prepare a report, it gives a template and everything. You have to be right into it. It's not like blindly you go and get something, but you have to tell it what to do. So then only you can get that. And the second rule, 6 to 10. Sixth one is beyond triple E. It is mainly after MTech when you have specialization on micro and real. Then you can get into it, but still there is some engineering gadget. It's very less. But the 7, 8, 9 and 10, they are the traditional, employment generators like government energy sectors, ABB, GE, Ashton, all those things. And the core engineering like aerospace, railways, defense, and all these things, if they are good with curriculum or they are good with course content, they can get through all these 7, 8. Their special skills are not required here. But the top 5, this is where we need to focus because these are the major job creators. So now with this 50%, the new jobs being created by startups. So after 5 years, what will be? When your Gen Alpha will come to colleges, what will be the situation? It will be the exact opposite. Maybe 80% will be startups and young companies, and the remaining 20% will be with big companies. Because even the big companies also, now they are not doing the order. They are giving it to some startups. Because when a big company want to do it, let's take an ABB. In ABB, one GED and the CU, between that, ground to space, that kind of, there's so many people out there. When they want to do something, all these costs will add up. And the same startup, engineering and CU, there is no one. If these guys can 1 crore to do particular activity, these guys can complete less than 1 lakh. So that is the reason, if you look at recent developments in strategic areas also like space, defense also, they are outsourcing all the work, major work, and encouraging startups to do that work. If you see recent last decade, how many space startups came, and how many defense related startups came, how much content of the work defense offered to startups. That's the same case with the big companies also in manufacturing or aerospace or energy. So people are leveraging the cost effectiveness of the startups. Instead of doing all their work, because they can define the requirement, they can get the order from startup because it's easy and they're paying very less amount to them. So the workforce is shifting from big companies to startups. So maybe when Gen Alpha students come to college, it will be 80% workforce is from startups and the remaining 30-35% is from the main major MNCs and established companies. So are we ready for that? How can we try Gen Alpha students for the industry readiness? So if we start more, and we still have 5 to 6 years of Gen Z students coming into colleges. So why don't we experiment with them and make them ready for the industry so that those processes and methods will be same for the Gen Alpha also. By the time Gen Alpha also will be ready. So now I'll go deeper into these couple of segments because the other things, once you have what I was trying to say, then you can interpolate. You can. So if you deep dive into clean energy. What is the content required? Whose content? Power process, yes, it is required. Why it is required? We have to use a AC to DC rectifier or a converter and machines. It's generator. And I think we will be having 2 to 3 semesters per machines, electrical machines. So, and in this particular wind generator, we use permanent magnet generators. Nobody uses induction generator or synchronous generator. So, permanent magnet generators. Do we have any course is touching upon the permanent magnet generators? Maybe we will be our course content will be like induction motors, DC motors, induction motors, and synchronous motors. That's the order of and the transformers, DC motors, and AC machines like that. And then we will be having some design course, AK Sahani, and maybe advanced machines of electric motors and those things will be there. But do we have any content, any chapter, one chapter on permanent magnet generators and how they work, what's the architecture of it?
Actually, there is an elective for these special electrical machines.
Okay.
Regular machines course is one thing.
Yeah.
We included PMSM, BLDC, SR, and all that in a separate course, and we made
And it's elective.
So this knowledge explosion is also leading to these issues.
Yeah.
See, some people opt for electrical machines, some people opt for a different course like that. We include it in the curriculum, but I can't say how many people actually choose it as
Because this to implement in the college, it is very easy because one of my friends' company is making this turbines. It's just this much height. Easy to experiment, and you can work on some the PMG generator concept. You can easily fabricate it. It's not a big deal. And DC-DC converter, you can work on something. You can try to do some improvements in that. Anyway, we do experiments, right? In lab, we do some load tests, no load tests, all those things. Why don't we put this? We do testing options with respect to the airflow. What is the power you are getting? What is the voltage you are getting? Anyway, experiment is to record something, right? Do something, recording. So this is the easiest way to do it, and this content is very relevant to the industry. And the control systems. We study control systems. It's only one course, as far as I remember. Only one subject in one semester. We increase the content.
Actually, there used to be control systems and advanced control systems also.
Oh, advanced control system.
digital control.
Digital control system.
Those days we used to have 3 courses. But currently it has come down to a single course and control.
So here control systems also, because when we want to control any motor, any inverter, anything, control system forms the basic scenario. PI controllers. How to tune PI controllers? Even today, industry, we do randomly. We have a set of rules, but ideally, you need to use a Buddha clock or root locus or Nyquist clock to derive the basis of that, the beginning of it, the initial parameters. Most of the times, once you get the initial parameters from any of these 3 systems, you can immediately close it. You will be close to the final parameters. But how are you using that? Even industry, we don't use that. Nyquist plot or Nyquist plot, we don't use. Border plot sometimes we use. Root locus also we don't use. Border plot we use sometimes to derive the initial set of parameters. So more it is like PD control we don't use. PI also don't use. It's only PI in all industrial controllers. So some kind of tuning exercise. I mean, in your anyway you will be having experiments. So take evaluation kit where you will get hardware, firmware, mode, everything. Any chip maker is giving now less than 1 lakh rupees. So test it, tune it, change the parameters and tune it. So that is where even students also will get interest of what industry is trying to do. Otherwise, the knowledge, the textbook knowledge is different, and the knowledge required by industries, that is different. And some kind of laboratory experiments, the PV characterization and the MPPT implementation for the solar. And solar also, keeping a solar panel in the lab or keeping outside, you install somewhere and take the data of it. I mean, and wind integrated, and there again the control will come into picture. When you are integrating 2 sources, what to prioritize and how to take in a controlled manner, again the control systems and power plants will play a major role here. So setting up a facility for this is not going to take much of your efforts, but it's going to give students a vast knowledge of the industry readiness perspective. And some kind of projects and internships. I'm not sure whether we have an internship system here. When we are studying, there are no internship.
Yes. It's mandatory. Everybody has to do an internship in 3rd year summer, again in final year second semester.
Second semester. So, as a startup founder, internships are like they are the driving force for us. My entire the entire drone platform is being designed down to interns. So one engineer from Gokara, he is handling complete firmware independently, no guidance, nothing. And one engineer is doing complete magnetic design. He gave certain hand holding, but now that engineer is the owner of the complete magnetic design of the motors. And one engineer is doing complete mechanical design of motor, ESC, and a complete drone component system. They are GEDs, and now they became GEDs. They were intern. Last 6 months they were doing that, and in September they launched a drone system. So if I had to do it with experienced engineer, it would have costed me crores. So that's why I like the concept of internship. So last year we took around 10 from Gokara and Andhra, and this year also we have some internship. We have some engineers we can definitely take. That's good for them also. They will also get the first-hand knowledge. Instead of definitely books will give some knowledge, but the projects is the ultimate. It's kind of experience. And when you are working in a startup for 6 months, is almost 2 years experience in the established companies. And this is about the clean energy. So the point I was trying to make is like course content. I mean, if it is in your hands, if you can do something, add some courses related to this and include what is required here, there, and experiment. Bring that to experimentation like DC-DC converter, small DC-DC converter design, or rectifier design. That, I mean, not a small piece in which we all can make. I mean, nowadays engineering students are very fast. They are very attentive, and they are very proactive. They are learning very fast. Another propulsion side. So why I was saying propulsion is not a single domain. You look at the applications, mobility, 2-wheelers, 3-wheelers, 4-wheelers, buses, trucks, and on the aerospace side, drones and VTOLs, vertical takeoff vehicles. And there, so much R&D is happening, so many startups are working on drones and VTOLs, and the humanoid. And if you look at all these systems, and UGVs and AMRs, now we are fascinated by this 10-minute delivery and 30-minute delivery. So all of them needs big giant warehouses, all these Flipkart or Amazon or anyone who is delivering something to you, they all need warehouses. And there, if they do everything manual, the picking and placing, they need so many people. So that is why now AMRs, automated mobile robots, are filling that gap. It's like their warehouse is a defined structure. AMR will go there, pick the box and deliver to the guy who is taking that. And so many startups are working on it, as well as UGVs, the one I spoke about, the agricultural machines. You see everything there, everything we import from China, not in its full form, and the components inside all those things we are importing from China. We still importing from China. Drone, if you see, 90% import from China. The motors, propellers, controllers, even the flight controller, even the remote control also they are imported from China. So propulsion is a very generic and a very, it's a kind of ocean where the job opportunities are huge, humongous. And now, all these propulsion related, motor is the center point, and then the power electronics, controller, and the gearbox is the mechanical stuff. So motor, power electronics and control. In the application, that's the common point. So it is not like a different segment or it's a single segment with multiple applications. So now again I am coming back to that. So electrical machine, we still have the DC, AC and all those things. But these systems will start from BLDC. Majority of the systems will use BLDC motor, and then some advanced cases they go for PMSM motors. In PMSM also there are wide variety, surface mount, interior again, synchronous electrons, hybrid synchronous electrons, hybrid IPMs, switched electrons, synchronous electrons, axial flux. Now they became mainstream. Now DC motor, synchronous motor, induction motor, they are not the mainstream anymore. Even if you take consumer appliances like fans, now BLDC fans are coming. And even all the washing machines, refrigerators, everywhere BLDC is taking over because of its advantage of cost and space, all those things, power density, those things. So we need to start, treating these technologies as a mainstream rather than special. They are not special anymore. They are all in our household now. BLDC motors are in our household. All dealers are using BLDC motors only. Whatever you see, the delivery boys use this hub motor based. They are all BLDC. Only a premium OEMs are using PMSs. And even the entry level 3-wheelers are using BLDC motors. But when you need more than 5 kW power, then only we are going for PMSs or some advanced technologies. So we need to start thinking, in terms of the making, these motors, these technologies as mainstream. Because what they learn is different. When the induction motor principle is different, synchronous motor principle is different. But when we put them on these technologies, then it's a complete shift for them. So we learn this because the design they learn, like we have to do equations and all those things. But nobody uses equations in industry. It's all digital design and virtual validation. Nobody uses so much experimentation also. It is all in the virtual validation, like we use finite element analysis. So the base for finite element analysis is the electromagnetic fields. I think we still have that subject, EMF theory. So that is the base for all simulation software. If you are good at that, and if you know finite element analysis, you can work with any simulation, model design simulation software. But for EMF, the base is vector calculus. For us, we study like a silos, vector calculus in one semester, one subject. Once the subject is over, we forget that. And that's the base to EMF. That is in a different semester, different subjects. And the EMF should be the base for the electric machines. So, but it is a silos, different silos. If we relate all these things, then definitely a student will have a very good understanding of the fundamental concepts. So, even if the technology changes, the basic physics doesn't change. Any motor, two fluxes will interact, then the torque with forces will generate, tangential forces will generate, and it will convert like mechanical energy. So how those two forces you are getting? I mean, in induction, because of the cage, you will get the second flux. And in permanent magnets, we have permanent magnets. In external excited generic way of synchronous motors, we have a DC winding on the rotor. We use slip rings. Now, people are removing those slip rings and putting like a wireless rectifier. And there are so many patents on it. There are so many companies working on that. Maybe billion dollars of funding is flowing into the companies. Finally, it is an age-old synchronous motor. Three-phase stator and the electromagnetic coil on the rotor. We use slip rings to pump the DC current to this. And now that since slip ring is cannot be put in any of these kind of systems, they remove the slip ring and put a rectifier. Wireless kind of rectifier to convert AC into DC and feeding rotating rectifier, because DC the field winding is on the shaft, so it is rotating. So now that's they call it ESM, externally excited, electrically excited synchronous motors or one phase synchronous motor. So billion-dollar investments are going into that technology. And when you look deeper, it is just a synchronous motor. What we study.
Does it become the magnet-free motor?
No. Because we don't use synchronous motors because of slip rings and brushes, because it's a maintenance kind of. So now they're replacing, and now it is becoming like a magnet free motors. Billion dollars of funding. And there's so many patents on that. Incremental change. Even when we are studying, when we think about innovation, it will be like a rocket science or something. But every invention is not rocket science. I mean, even some incremental changes. I mean, what is this bringing? What the change is bringing? So that matters a lot. And the power electronics. So none of the applications uses motors as a standalone motor. Every application needs a inverter because we need a controlled output. So you need to control the input. So every motor will be supplied with an inverter, with a controlled way, like a motor control we call it, an inverter we call it. So power electronics, I think we have only one course again for power electronics, or it comes with 3-2 or 3 courses.
Third year first semester.
Third year first semester. That's the only one course.
No. That's a basic course offered, and beyond it they study a course like Amiram for renewable energy.
Renewable energy.
Power electronics specifically for renewable energy.
So I think this is where because we can't treat motors and electronics, as separate things. This motor, power electronics, control system. This is not a single, subject and single application only. So we need to try students in that way. So we need to put experiments. I don't know whether we have any BLDC or PMSM based experiments in the labs, or it is induction motor or DC motor.
We do have a BLDC machine procured. Actually, an experiment needs to be implemented. We have purchased actually BLDC.
And the inverter testing, because nowadays we are getting all the evaluation boards ready to use. I mean, whatever you are doing on the conventional machines, you do the same thing on these machines. So at least student will get an exposure to the new technology. Okay, this machine will behave like this. If excitation is like this, the outcome is like this. If you vary this parameter will vary. At least the curiosity around the new technologies, has to come from our labs. Because books can't give, we can't build curiosity with just books. We have to, establish some kind of experimentation towards these segments. Maybe if it is in your purview, it is high time to start looking into it and reduce the conventional content and map new kind of new or industry needs, how we can incorporate industry needs into our experimentation also. And the same way, I mean, you can do some mini projects and major projects, and especially internship. Now, when we say propulsion, there are so many companies, maybe 1,000, 10,000 of companies are there. And so many startups also there. They are looking for interns. So if you can send your students there, they will get the first-hand exposure of all these technologies. Now, it is like an exciting time for all the new technology. I don't know how long this excitement will be there. So try to capitalize on that. Even because you are a major pillar, in the ecosystem. You are bridging the gap between industry and the students. So it is high time that you need to, relook into the content. If it is in your control, just try to tweak it a bit so that the students will become, industry ready. And for each segment, as some how you can, do some experiments. Like suppose for the vehicles, electric vehicle technology. I mean, do we have any lab here or in any of your colleges? Do you have this? Now most of the colleges are implementing this kind of experimenting, and there is a big business model coming out to create this kind of test vehicles. We call it lab cars. So this is a two-wheeler. Whatever is required for motor, controller, only these things will be there. You can get a plan there. Suppose you want to do some experiment. I mean, just I apply throttle with respect to speed. How much DC current is driving, how much AC current. Experiment is safe, that's the only thing, right? We do some test, we record some parameter. So why don't you test on this? And the charging times, charging cycle, how it is behaving, and the DC-DC converter, and what is the architecture of two-wheeler, three-wheeler, and it will be fun to most of the students. They will get engaged like this. And I don't know whether we are participating in any Baha or this track events from Melbourne.
Here we have mechanical engineering faculty members also.
I saw some vehicle there outside.
Yes. Mechanical department used to send their team regularly, and that team consists of all interdisciplinary participants, students like electrical, AIDS, computer science, mechanical mostly. But along with that, electrical, computer science people also do involved in that making that e-Baha.
So it should be driven by engineers.
I think we have an in charge of.
It should be driven by engineers.
We have a participant also from there.
One of the participants
It is
is
electric vehicle or it should be driven by engineers, not someone else. Because we are working with many colleges because they take kits from us. So when we interact with them, the kind of exposure they have on the vehicle technologies, they even know how to configure canvas. We don't teach in colleges. Scan matrix, scan bus, those things. But that is the basic protocol when you enter into the industry. You take the data, you capture the data. So this is easy way of implementing experimentation towards electric vehicles on the vehicle side. And this is an easy level, less than 1 lakh rupees. That's a gold card. And this is a rickshaw. And this is a two-wheeler. You can get the gold card will be costed. That was something less than 1 lakh you can put. But you can capitalize on that heavily. Students will understand the architecture. What is EV architecture? And the components. When they see is believing. Even students also, when they see it, then they get a first-hand experience. And the charging systems, the infrastructure, and how each motor is behaving. I mean, each motor, this is a hub motor, it's an outrunner. I mean, what will be the outrunner? And this is, they call it mid-drive, in-runner, inside rotor, this is the outside rotor. And how that axle is connected, what is the different diameters, what is the BMS, what BMS is doing, and we can calculate BMS also. And in battery cell balancing is there. Those are the basic, EV related, technology related things, and can be implemented easily without so much funding requirement. And many colleges implement it already, especially in the southern part of India.
we do have an EV lab. Some of them we include.
Okay.
We have battery testing, state of health, state of charge.
Yeah.
And now we included the two-wheeler setup is there.
Yeah. Then if you add experiments also, you
add
add
some.
Yeah. Then it will be at least they will get an exposure, first-hand exposure. Okay, this will not be final vehicle when they work for actual vehicle. They will face a lot of other problems, but at least they will have a basic knowledge. And drones. As I mentioned, most of the drone components are being imported from China, and even now it has got to a level where people are smuggling the entire drone to India to avoid duties. So it has reached that stage. Now that is the Indian government has restricted the certification, DG certification. If you are importing anything, we are not going to certify the drone. So now everybody is behind the indigenization. Everybody is looking for some locally developed motors, controllers, and flight controllers. And these motors can be whatever you are seeing on the right side is a thrust stand. Thrust stand. For motors being used in drones or aerospace application, we don't talk in terms of torque and power. We talk only thrust. How much thrust it can generate. So the thrust stand is like almost like a dynamometer. How you measure this torque in dynamometer. So this is like a dynamometer for the aerospace application. This is also not costly. You connect the motor, ESC and propeller to that, and you can get all the data with respect to speed, how much thrust is being generated, what is the efficiency, and a complete efficiency mapping you can do. Because drone motors you can't do testing with regular dynos. These are easily available in India, also available. You can tweak some experiments around this drone motors and components. And after, experimentation is the first stage, and then you can ask them to tweak the designs. Once you have some basic design software, the drone motor design is very simple. So you ask them to change something, and then see the performance, whether it is really changing or not. Because whatever you are expecting, suppose you change something, you expect something, whether that is coming or not, the validation part. So you can start with these things. These are simple things, easy to implement, and on the returns wise, the ROI is very huge in terms of students' knowledge and readiness towards the industries. And the next big thing is humanoids. So each humanoid needs 25 to 30 actuators. Actuator is nothing but a motor and controller together. We call it different name, but ultimately it's a motor and controller and a planetary gearbox. For this meeting, and let's keep the gearbox aside. It is just a motor and controller. Each humanoid needs any movement, you need a motor. Wrist movement, this movement, or like this, or this shoulder movement, or neck movement, everywhere you need a motor. Almost 25 to 28 motors are required. And these experiments are really fun. And you can tabletop setup. Take one actuator and connect an arm, and all the actuator supplies, they will give a open source software. You can easily pull the parameters, and PI parameters will be there, and you can see whether it's just movement, whether it is going to the movement or not. So these experiments will be fun, and this is going to be the next advanced segment in the propulsion area. So you can easily put these kind of test benches. Even we have some test benches like this. And at the end of the day, this is also a motor. Everything is, any application centers have a motor, power electronics, and a control system. So you have to create many experimentations or lab assignments around the mini projects or internships. That is why I put one slide for each application. And the AMRs and UGVs, they are also the experimentation around these things will be like fun. You can track a line whether the AMR is following the current because it's automated mobile, it has to follow that line. So you can tweak the control parameters and see whether it is going in the right path. And experimentation has to shift from papers to these kind of activities. Then the students will get interested. This definitely it is like fun, but at the end of the day, they also gain some knowledge and they will get exposure towards the new trends of this. And this is again AMR and a robot. This is a test bed kind of thing. You can take this and do whatever testing you want to do with this. And there are some UGVs also. You can get easily from the market. This is what I was talking. Any chip maker like NXP, Texas, Infineon or Microchip, they are supplying evaluation board like this. So if you get this board, this is completely open source. You will get the schematic so that you can study. Your students can study how the power schematic, how the motor control schematic is, what are the things they are taking care. and they will give the firmware, all the control logic to control this motor. So you can study that what is the architecture, what is the code flow, and where you can change. Again, same way here also, they will give a beautiful GUI with all the PI, all the control parameters. Instead of big machines and big dynamos, you can easily put this in the labs with minimum capex. It doesn't require any capex at all, maybe 10,000, 15,000 rupees like that. But so much experimentation can be done around this. Motor related experiments can be done, control related experiments can be done, and even control logic related experiments can be done. Even hardware also, you can change the hardware and see. You can increase the motor rating and see. And wherever you want, you can tap the balance, voltage, or you can all chip manufacturers are giving this kind of, they are available on element 14 or online. You can easily purchase these kits, and they are going to give immense knowledge to the students. And this is a no load. You can't load this. So how do you load this? Back to back setup. So even this is also being provided by companies, these chip companies. So you can directly get that, and you can do load test also. With load, how the system is behaving, how motor is behaving, how control is behaving. Because sometimes when you do PI tuning on no load, it doesn't work on load. So you have to tune on load also. So those scenarios you can use this. Or you can establish a small tabletop test bench for low power. You don't need to go for the kilowatt level power, just watts, number 100 watts or 50 watts. The most of the applications are less than 100 watts. Even humanoids or drones, there are very less power things. If you take EV, it's high power. But for the experimentation purpose, you can restrict to this. The scale up is always possible. I mean, when they go to real industries, when they are working on that, at least the knowledge is same, whether it is small or big, knowledge remains same. So these are implementable, experiments. And now, because the other segments, with this thought process, you can see for the other segments how to alter or tweak the course content at the labs, and how to incorporate mini projects, internships, or main projects. And now digital literacy, to do all these things. Any industry, take any industry, nobody is doing any design with hand calculation for Excel spreadsheet based calculations. Everybody uses some commercial softwares or open source softwares. So if you take motors, nobody uses whatever the methods mentioned in AICTE or any other test book. So either ANSYS has two softwares, electronics and AutoCAD. We can use either of that. And Siemens is having Flux Motor and Motor Factory. Motor XP is a new software which it was until recently it was open source, but now they are charging some minimum amount. And FDP is an open source, but to use that you need to have basic knowledge of finite element analysis. So I mean that's up to you. I mean if your students can work with that, they can take this completely open source. Anybody can install any laptop, and then they can start working on motor designs. And these companies, student versions are available. So for universities or academic institutions, they give it for free. I mean, you can ask your students to tweak the motor because they have so many examples in that software. So you can open one and change this, what will happen? Change this, what will happen? Iterations. Because design sometimes you learn by doing simulation. When you are doing one particular design simulation, by seeing that, you can okay, if I change this will happen. If I change, like experimentation, like virtual validation we call it. And the same way for software, I suppose, we all have matters simulating, but in that what we are doing, what level of power electronic circuits we are simulating in the simulation. Whether they are basic level or we are introducing real-time problems, and PCM is there, LT-SPICE is there, all student questions are available, and the power system simulation. Now, this is also gaining prominence because previously the grid is mainly by major power sources, but now we are adding so many micro generators like wind, solar, and the BESS. Now battery energy storage systems are gaining prominence. So all this is becoming like a hybrid grid. Big power plants are there and the micro generators are there and the BES charges are there. So many companies are doing this load flow studies, the power system studies using this ETAP and PSCAD. So you can at least start with some basic things, at least how to use that tool and the minimum basic circuits or basic load flow problems. If you start that, then at least when they go to industry, they are like from day one, they can start working on it. The remaining things, that will be taken care. How to hand hold. If it doesn't know anything, it's difficult to handle. If he knows something, then hand holding will be easy. If not from day one, he can start working on the project.
Actually, our department has both ETAP and PSCAD licenses softwares.
Are we using it for experimentation?
We started using, not in a big way, mostly we use MATLAB. The little we added, PSCAD experiments added.
So ETAP PSCAD now, because power system, the overall grid is becoming more of hybrid kind of nature. Initially it was not hybrid. Only big, all these because of these micro grids and the BESS. So it is becoming complicated. So much work is happening around that. So many simulations, or so many startups are working on that also. So as an extension to power systems subject, you can include some kind of simulations in the ETAP, like flow study, load flow studies. Most of things are available in the open source, like the bus texture and all those things. Standard activity 32 bus or something will be there. So you can include these kind of experiments so that it actually give like real-time experience to students. And the same PCB, whatever we desire, whatever we need, there is no electronic circuit or PCB, we can't do anything. So most of the colleges are using this open source KiCad or EasyEDA, small circuits, and you can ask them to make a small circuit schematic and make a Gerber PCB, fabricate it, test it. Small circuit, maybe a rectifier or a simple MOSFET, controlling the MOSFET or some kind of buffer converter. So EasyEDA is a completely open source. KiCad is completely open source. So a lot of the last years, they are all well versed with KiCad. They already designed some kind of PCBs. So this is easy way of implementing. Some small circuit. Let them experience the process from design to the fabrication and the texture. So then that can be scaled up when they come to industry. If they know the process, then it's easy for us to hand them with their projects.
Students already started using KiCad, sir.
KiCad, that's the completely open source.
And also EagleCAD, the CAD version, EagleCAD. And they are making a bit adapter, like rectifier.
Yeah.
Rectifier circuit, and followed by some gate driver circuit also.
Yeah, if they can control a MOSFET, gate driver, PWMs, and with a controller like Texas or Infineon or microchip. But not Arduino kind of things, proper industrial controllers, they're good to work on and motor control project from day one. If they can at least generate a PWM with their own hardware, from not on the software, their hardware, and on their firmware, if they are able to generate PWM and know how to control the MOSFET, then that is sufficient for us to start putting them on the project.
As a part of skill-oriented courses, they are being involved in making in-house PCB fabrication, and as well as the bigger one, which is a 2-layer, they are being ordered with some other vendors. Right now, they are doing.
Yeah, fabrication you can do it from anywhere. Fabrication should not be an in-house one. Fabrication
small thing they are doing.
Yeah, when you see motor control, it's almost like 4-layer or 8 layers. 2 layers is not sufficient. This one, motor control kind of. So at least start them with single layer or 2 layer, whatever is possible. This is not a process. You have to teach them the process. Suppose if they want to design something, where to start and what are the different steps, and when they can confidently say that okay, this activity is closed, this project is closed. If they have that overall broader knowledge, then they are ready to be on the projects from day one. And the same way embedded systems also, they are all, except Infineon, everything, all the development environments are open source. You can start with, when whatever controller you are working on, you can, basic software will be available from from chip manufacturer, but we can start some basic things. And electrical design, like AutoCAD, electrical, these things are not that difficult. But the top 5, I mean, I'm not saying each student should be well versed with all these things. It's difficult in the span of 3 to 4 years getting them to know all those things. But at least one group, one technology or one software or something like that based on their projects or their interest. If you have that, at least by the time they come to the industry, they will be, like industry ready. And yeah, I think this is going through my last slide. Yeah, and just since I am from the motor background, I just wanted to explain you the flow of how motor design will happen. If you want to design something, it doesn't start with the equation, it starts with the constraints. Suppose if you have designed a drone motor, so first we get constraints of the boundary. This is the space we have. We have to start with the constraints, not with the equation. Then we use RMSF for the basic simulations. So we'll put everything on the, it's like the 1D simulation, we'll get the basic output and then we'll take it to MotorCAD for the multi-physics. And it's a 1D level, it's not a 2D or 3D FE, it's just a 1D level. We do it then. Here, in MotorCAD, we do so many iterations, maybe 100 to 200 iterations. Then we will finalize one design and that will go for 2D and 3D. So once we finalize the base design for the waterfront, then we take it to Maxwell 2D and 3D. There we use finite element analysis and we see all the things which we cannot see with the equations or as well as 1D. Like we even see how flux flows in the motor. We always say that rotating magnetic field, right? How is it? How it will rotate? How it will be? And where the metal is getting saturated, where it is not saturated, where the flux is leaking. All the macroscopic studies we use finite element analysis. And the finite element analysis in conjunction with electromagnetic field theory, whatever we study in the engineering. So these two together is the basis of any two-dimensional or three-dimensional motor design software. Once it is okay here, then the electromagnetics part is okay, and then it will go for some mechanical and CFD. So mechanical we do structural analysis whether it can hold the load, the body can hold the loads or not. And in NVH, the patterns and the noise patterns, what are the orders, harmonic patterns, what are those things we will, and then it will go for a system level simulation. Now, all these simulations are only with the sinusoidal excitation. But real time is not a sinusoidal, it's a PWM based excitation. So then we go to that final simpler software and we add the physical model into the circuit. So at each time step, circuit, once the circuit is solved and then it will come to final element, it's like post-simulation. Then we get a complete picture of, like how the real-time motor is being tested. We'll get a complete picture with the system validation software. It's not simpler. So this is how the motor design flow. This is using ANSYS. The same way flux motor is, AICTE is having a different flow. And the sim center is having a different flow. So every software is having a different flow. But the fundamental is same. We have to go from this step to that step for any design. Even the power electrons, maybe the physics will change, but the flow will remain same. And if you see here, when we say electric motor, it is not just electric, it's a multi-physics. Electrical, mechanical, thermal, everything will be there. So at least the cross-functional understanding should be there. Any designer, you cannot become a better motor designer without knowing the basics of mechanical thermal analysis or the thermal concept. Otherwise you can't design it. If you do thermal, motor controller, it is more complex. more than mechanical and thermal, you have EMI, EMC, there are so many other complicated things are there. So, yeah, focus on everything that is better, but the basic things, because we do have some subjects, right, like strength of materials, engineering mechanics. At least, I mean, focus on that also. I mean, because in the industry, that's going to save you a lot. Because not in any corporate or anything, if some problem comes, it is like it's not my problem, it's not my problem, madam. Then your cross-function knowledge will literally save you. Because the mechanical engineer will put a blame on everything, you did not design properly, and he will put a blame on the other guy, he did not design the casing properly. But when you have a basic knowledge, then you can, you know, that is the way to survive in corporate, especially Indian corporates. So students should have sufficient cross-functional knowledge also, otherwise they will be lost in this kind of corporate fights when they go to that level. So the same way for controllers and all those things also, there will be different flows. So ultimately, I mean, the purpose of me coming here is like I just want to put my requirement to you, to bridge the gap between the current requirement and the graduates, the knowledge of the graduates coming out of the colleges now, so that at least if it is your requirement, maybe you can tweak course content, maybe some experiments or some projects related to these advanced techniques. I mean, if not motors, there are so many other segments are there, so you can focus on that, so that students, the workforce coming out of the colleges will be industry ready. That's the whole point, because most of the startups, like our startup, is being driven by interns only. So here this is the last slide. Yeah. So I can take question and answers.
I think we can have a break and then come back. It's fine.
Yeah, it's fine.
So have some snacks, come back, we'll have a thorough interaction. You can have questions and find out what best can be done for your students. Because he's having a wonderful experience in not only motor design, working on EVs, drones, whatnot.
Session start 3:40.
15 minutes, 10 minutes break?
Yes.
ఇది లైవ్ స్ట్రీమింగ్ దానికి పెట్టి ఇది రెండు మైకులు కూడా పెట్టినా ఇద్దరు మాట్లాడుతున్నా వీడియో ఇక్కడ పెట్టి ఇద్దరు మాట్లాడుతున్నా మ్యాగ్నెట్ ఇచ్చారా మంచి పని చేశారు మైక్ పెట్టించి ఇదొక ఆయన ఆయన ఫోటో పెడతాను తండ్రి కదా
స్నాక్స్ తీసుకో. ఎవరిని పర్వాలేదు తీసుకో. ఈరోజు